Hello, thanks for stopping by our paper. My name is Siru, and I'm currently a second-year CS-PhD student at UIUC. I'm very glad to walk you through our paper, One Fact, Ontology Enrichment for Effective Fine-Grained Anti-Typing. One fact targets the task of zero-shot fine-grained anti-typing, where the input is a sentence with a given anti-mention, and we expect to obtain the anti-type label from a predefined set of types, which is usually organized as a structure. And we refer to it as ontology. We visualize one such example in the right side of this slide. Typically, directly prompting LLMs does not handle very well with such task. We conduct an error analysis as below. We can see that large language models often lack sufficient word knowledge and will conduct incorrect inference of fine-grained entity type levels. And also, there are some nested anti-span identification issues. Therefore, how to fully interpret and leverage the structure of ontology really matters in this task. We propose one fact, which leverages the enrichment of ontology structures. Here is a brief framework of how one fact works. Firstly, we will enrich the ontology in terms of instances and topics, after which the instance and topics are used for training a natural language inference task. And finally, the frozen NLI model will be used to conduct a recursive course to fine-grained anti-typing on this specific ontology structure. So for ontology enrichment, we will enrich a specific node with instances and topics. For example, in this case, with athlete as the anchor, we will enrich it with Matt and James as the famous sports players instances. And we will also enrich it with topics such as training. After we obtain the instance and topic information, we will first use instances to generate a context surrounding it. For example, given Leonardo da Vinci, we will use the language model to help generate a context that is feasible and understandable with respect to this specific entity. However, it is not just enough to generate a plain context. Here, we propose a contrast training data construction approach to help better distinguish fine-grained semantic meanings. Here, we use entailment, neutral, and contradiction as three specific categories. And then the topic information will be applied to gated attention with topic embeddings, where we will finally use them and apply GCE laws to help deal with potential noises in this synthetic data set. Here, I demonstrate some experiment results of one fact. We can clearly see that one fact outperforms previous baselines by a really large margin. It sometimes shows great performance that is on par with supervised settings. And that is all for a brief walkthrough. If you're interested in this paper, please refer to our preprint for reference. Thank you.